Hi everyone, my name is Annika and I'm part of the Data Science Discovery team, and in this video today we're going to be doing a question on distribution likelihood. So let's go ahead and get started. So it says here you run the following code, right? This is the code you run. What describes the likelihood of Python randomly selecting an 85 compared to all of the other values? So first, when we go ahead and look at our actual code, right, the random.choice is basically acting as a random generator, right, that chooses between any of these values. So we can assume that this is a random generator. Although some might say it's pseudo-random, it is a random generator because each of these values, the probability of choosing any of these values is basically 1/5, right? So it says here, what describes the likelihood of Python randomly selecting an 85 compared to all of the other values? Well, we can say here that it's basically going to be 1/5, right? Because 85, the probability of choosing 85 is 1 over the total number, the total amount of values we have in our random generator, which is 5. So the likelihood of Python randomly selecting an 85 will basically be 1/5, which is the same as the likelihood of picking 81 or 82 or 83 or 84, right? Because both of all these numbers occur once out of 5 total numbers. So we can say here that, the likelihood of picking 85 is the same as the likelihood of picking any of the other numbers, right? So we can say here that answer choice E, it is equally likely for each number to be selected, would be the most representative, would be the correct answer here, because the probability of choosing any of these numbers is the same, right? It's 1/5. So we can say here that answer choice E would be the correct one here. Now, if we go ahead and generate another instance of this problem, we can see here that our random generator is different, right? And we can say that what describes the likelihood of Python randomly selecting 33 compared to all the other values? Well, we can see here that out of these 1, 2, 3, 4, 5, 6, 7 values, right? Out of these total 7 values, 33 occurs 3 times, right? So the probability of picking 33, which occurs 3 times out of 7 total values, is 3 out of 7, right? Which is, basically it's almost 50%, right? And we can say here that it is, when we look at answer choice A, it is equally likely for each number to be selected. It's actually false, right? Because the probability of each number being selected is basically 1/7, right? And then so A is false, and compared to all of the other numbers, it is twice as likely for 33 to be randomly selected. Well, 33 occurs 3 times, while all of these other numbers occur once, right? So the probability of picking 34, 35, 36, and 37 is 1 out of 7 respectively, right? But the probability of picking 33 is 3 out of 7. So we can say here, and I apologize if I said about 50%, it was actually about 3 times as likely, right? So compared to all of the other numbers, it is 3 times as likely for 33 to be randomly selected, because the probability of choosing 33 is 3 out of 7, but the probability of choosing all these other numbers is actually 1 out of 7, right? So if it was 50% of the time, then it would have been like 33 occurs 3 times out of 6 total numbers, or 33 occurs 4 times out of 8 possible numbers, right? And then which is not the case here. And then part E is compared to all of the numbers, it is half as likely for 33 to be randomly selected, which would mean that if all the other numbers have a likelihood of, let's say, 2 out of 7, 33 would have to have a probability of 1 out of 7 for it to be half as likely for 33 to be selected. So we can say here that it's actually not the case, because 33, the probability of choosing 33 is much more, right, than any other value here, right? So the answer choice C, compared to all the other numbers, it is 3 times as likely for 33 to be randomly selected, would be the correct answer here, because the probability is 2 out of 7 versus for all the other numbers, it's actually 1 out of 7. And if we go ahead and do another instance of this, we can see here that this the likelihood of Python randomly selecting a 46 compared to all the other values, well, we can see here that there's actually going to be 8 possible values here, right? And the probability, like 46 occurs 3 times, right? And we can see here that all of these other numbers occur once. So similar to the last one, actually, the likelihood of Python randomly selecting 46 is 3 out of 8. But the likelihood of Python randomly selecting numbers such as 47, 48, 49, 50, or 51 is 1 out of 8. So we can see here that 46 is 3 times as more likely to get selected than any other random number. And, as you kind of go on, you start to recognize the pattern of these random generators, right? We can see here that every single number occurs once. So there's an equal likelihood. But if we go ahead and go on to another example, we can see a certain number, like 23, occurs much more than any other value, right? So the key to solving these questions is really finding the probability that a certain value, the one mentioned in the question, the probability of that occurring versus the probability of all the other numbers occurring, and see kind of what the ratio, what the difference is, so that we can pinpoint exactly what is the difference and what is the actual likelihood of some of these values occurring versus some of the others. So I hope this video was helpful. If you have any questions, let me know, and I'll see you next time. Bye.